Good afternoon everyone. Thank you for joining me for this review video today. I am Mr. Ish. I hope you've all been enjoying my previous videos. Now I have to confess that a few days back I was looking at my very first video in which I was discussing the definition of functions, and as I was looking through that video I noticed that I could have probably done a much better job with it. Already the definition of function concept is a pretty confusing one, and then if it's not well presented, the whole confusion is not dissipated with a bad video. Rather, you need a video that presents the material very well to help eliminate that confusion. The problem with the definition of functions is, like I stated, is a confusing topic and a confusing definition to begin with, because it's not very clearly expressed in a single sentence or two. Like exactly what is a function? You cannot really answer that in one or two sentences. You have to end up bringing in examples and scenarios to help clearly get the idea across. So in this video, when I revisit this topic of the function definition, I will plan to do just that. I want you to all think about functions as a rule. It is a rule which helps to correspond one set of values with another set of values. If this is a single set over here and this set is made of many elements, and here is another set and that in itself is made of many elements, you can look at the two sets in the following way. Set number one, or the first set, you can consider that as the possible x values which you run through your function. Remember, a function is like an expression or an equation. These x values can also be representative of your inputs. They can also represent the domain of your expression or the function, like the domain, the possible values which you can put into this expression. Now on this side, the other side of this function or this expression, we end up with another set of values or elements, and these are represented by y values. You can also think of them as opposite of inputs, rather they are outputs. And the opposite of domain, well then they are range values. If domain represents the possible values you can put into an expression, the range represents the possible values that you obtain or which are the result of the operation of that expression or function. If it has not become clear yet what a function is, it is very understandable, because now the second part of the definition of function, more than just the fact that it is a rule or a correspondence between one set and another set, are a bunch of conditions or exceptions that have to be put into effect. Some of the conditions are these. Condition number one would be that all possible values, x values or input values or domain values, must be represented by that domain. If you were to leave any of those possible values, that expression no longer is a function. So all possible input values must be corresponding to some result or output in this set. That's one condition. Another condition is this: not all possible range values or y values have to be necessarily represented by possible domain or x values. That's fine. Not all of these range values have to have some sort of representation. Another condition would be this: there must be a one-to-one correspondence between the domain and the range, or the x and the y values. What that means is that for a specific domain value you must have one and only one range value or a y value. If you put in a single x value into your rule or your expression or your function, it must generate only a single value as your output. You cannot have a single domain value or an x value giving rise to two separate range values. That would be a clear violation of the definition for functions. You can have, however, multiple domain values or x values all generating a single y value or a range value. Again, let me say that while it is impossible for a single domain value or an x value to generate two different y values or range values without it spoiling the definition of a function, you can have multiple x or domain values giving rise to the same value on the output side. It's okay if, however, an expression yields multiple range values with a single x. That's okay, but then you have to be fine with the fact that that expression is no longer a function. For it to remain a function, a single x value must result in a single y value. There must be no duplication of domain values. Now I know I've said a lot of sentences over there. I believe when I put all of these in terms of examples which are coming up next, it will become more clear. Now let's look at some condition examples. Here's one condition which I mentioned earlier. One of the conditions I mentioned that each of the x values in the set A or domain must be represented in terms of range values. A possible function would be true if you had the following results. Let's put it out over here. Now look over here. Each of these x values or domain values is corresponding to a specific range or y value. You can see this. All the elements of set A, 1, 2, 3, and 4 are represented by some resulting value or output. So this right here is good in terms of function. Now look over here. Each value of x or domain is representing only a single value of range. There is no duplication of range. There's no situation where in any of these numbers is any of these numbers is generating two values. We don't have a situation where, like, let's look at this number 2. Number 2 domain is giving you like a 4 and is giving you a 9. A single domain value giving rise to two separate range values is a violation of the function definition. But we don't have that in this set of values. So this right here is good. Let's look at this other table of values using the same elements from these two sets. This right here is my domain set. This right here is my range set, inputs and outputs. How about this? Let's put a couple of numbers over here. Now look over here. I have the elements. All elements are represented from set A. 1, 2, 3, 4. That's one of the conditions of functions. All the elements of set A, the domain, the input values must be represented in your function. But not necessarily all the range values have to be represented by that given rule or that given function. Look over here. We have possible outputs of 1, 4, 9, and 16. But we only show two outputs, 1 and 4. There's no 9 and 16. That's fine. You don't need to have full representation of range, but you need to have a full representation of your domain. Look over here. There's no violation here in terms of the domain definitions. Each of the x elements of this set A are equally represented. Each of these x elements, or by x elements I'm talking about this over here, each of these x elements corresponds to a single value of the range, which is good. And you have multiple domain values which are all corresponding to a single range value. That's alright. There's nothing wrong with that. So long as one domain value is not corresponding to two separate range values, that's fine. You can have multiple. All of these could have potentially been corresponding to a single range value. They could have all been pointing towards a 4. It would be fine. So this again is another clear definition of a function. How about this other set of values? Now take a focus here at this set of values. If you look at the values very quickly, you see that each of these domain values is corresponding to a single range value, which is fine. No single domain value is represented by two different range values. That is, you cannot say one is attached to two different range values. Each of these domain values is corresponding to only a single range value. As I said, that's a good condition. The only thing which spoils this whole function over here in terms of its outputs and the inputs is the lack of representation of this element number 2. For the domain to have been a true, you must have had a clear representation of all the elements of set A. We're missing element number 2, therefore we have a violation here of the domain function, and therefore this rule or this equation or expression is not a function. By the fact that number 2 element is missing and there's no corresponding range value to it, because it is missing, we don't have a function over here. I hope these examples were clear enough, but I will reiterate again. These are the conditions which make your expression a function. Condition number 1, all domain values must be represented by a single range value. Condition number 2, you can have multiple domain values all correspond to a single range value. That's fine. That's called range duplication. Range duplication is fine. Condition number 3, you cannot have a single domain value represent two different range values. That domain duplication violates the function definition. So you cannot have a single domain value correspond to two different range values. You could not do that. And lastly, you must have all the specific elements of domain represented by your function. That is, each of those domains which are within your elements, your input elements, they must all generate some value in terms of your range. I want to present this definition now in a next different manner, and I'm going to talk about the vertical line test. Let's focus our board on these two graphs. I have representative equations represented for these two graphs. The graphs don't have to be necessarily drawn to scale, and they don't have to be 100% accurate, because all I'm talking about is a rough concept here, a vertical line test. If a vertical line test can be drawn through a curve, assuming that curve represented a function or some expression, if you can carry that vertical line through more than one point, you see the vertical line here crosses here at this, and these lines are going towards infinity. The vertical line crosses and intersects. By crossing I mean intersects. If a vertical line crosses a function at two or more points, it is not a function. It fails the vertical line test, therefore it's not a function. Look over here. The vertical line crosses the curve over here at 2 points, therefore it's not a function. For a function to be true, the vertical line must have crossed that curve at only 1 point. The reason why it does not succeed in the vertical line test is because you have a concept of domain duplication occurring over here. You have domain duplication. What domain duplication means that you have a single x value here corresponding to two different y values. Look over here. Let's assume this number over here, this point over here was like a 5, 0. You have a vertical line extending through it and intersecting the curve at 2 points. You know what this point could be. It could be 5, hypothetically a positive 5, and down here you can have a 5, -5. Now look over here. If you focus your point on these two, your eyes on these 2 points, look here, you have a single domain value 5 and 5, but you have a duplication occurring in terms that two separate range values are duplicated or attached to a single domain value. So you have an effect which basically looks like this: 5, plus and -5. This right here is domain duplication, and it leads to failure. It leads to failure of your function to pass a vertical line test. It's a failure of this test. Now look over here at this. If you draw a vertical line through any of these circle curves, this is a circle, here's a representative equation of this circle. At any point, while you're going through the circle, you're crossing the circle at 2 points. Remember, it's a vertical line. We're not doing horizontal lines, we're doing vertical lines. If the vertical line crosses your function or your curve at 2 or more points, it fails the definition of function and it is no longer considered a function. And you can see again over here, if you look at this point over here, this point could very well have been, and I'm being hypothetical, right? It could have been 2, 0. And then of course up over here you'll have some value 2, y, and here you'll have some value 2, -y. But you have duplication going over here, and the duplication is in this form: 2, plus and -y. So as I've shown you how we develop the coordinates 2, plus and -y, anytime you have a situation where a single domain value is corresponding to two different range values, you have duplication effect going on, then we can say that that specific curve or that expression was no longer a function. You may have thought it to have been a function, but it was not a function because it failed the vertical line test. To pass a vertical line test, that vertical line must cross your curve through a single point only, not more than one. I want to show you an example where the vertical line test is passed, where you succeed in defining that curve to be a function. So I want to show you these two graphs: x squared minus 2y equals this. Y is the same as f of x. F of x equals x squared minus 2, and f of x is equal to square root of x minus 3. These are both graphs which are curves of a function. They will both pass the vertical line test, and this is the reason why. If you draw a vertical line anywhere through this, a vertically oriented line will always cross this type of graph function at only one point. Look over here, another vertical line will only cross it at one point. But that's fine, and that's exactly what we want. And look over here, if we look at this point over here, right here, and we draw a horizontal line through it, we can look at these specific x values over here. We can have a possible x value over here, let's say 4, and that would be a y. I'm not calculating the y value here, but if I had a 4 coordinate x over here, we would have a positive y. But look over here, if you come exactly down over here, because it's a symmetrical graph, even on the right, even on the left, you would have a -4, but you would have a y over here. The same horizontal line would cross to the same y value across, but that's fine. We still don't have domain duplication over here because we have this going on. We have a 4, y, and we have a -4, y. We have two separate domain values corresponding to a single range value, which is fine. That's range duplication, but range duplication is fine. Range duplication does not spoil your definition of function. Range duplication would look something like this. You would have two separate x values corresponding to a single y value. Plus and minus x, y. plus and minus 4 comma y. Range duplication is fine. It has no bearing on the definition of your function. It has no bearing or effect on the spoilage of your function, because parabolic functions are all true functions. They don't pass the horizontal line test, but we're not talking about the horizontal line test. We're talking about the vertical line test. They pass the vertical line test. You have two different domain values, but they correspond to the same range value. Range duplication is fine. Now look over here. There's absolutely no instance where we have this effect going on. We have no instance of this, where we have x comma plus and minus y. X comma plus and minus y would be domain duplication and would spoil your function. We don't see that at all over here. We have a clear function all the way through. Just like this, linear lines are also clearly functions. You can have logarithmic functions, exponential functions, natural log functions. They're all functions. Even sine and cosine, the trigonometric functions, they're all functions. So remember again very clearly, a function is a function if there is a clear rule or correspondence between the domain and the range. Each element of the domain must correspond to a single value of that range, and all the elements of the domain must be represented by that function in terms of the generation of the y values. And there can be instances where not all the range values are represented. That is, each or multiple domain values can give rise to a single range value. That's fine. And lastly, remember this: if a single domain value gives rise to two or more separate range values, that is, you have domain duplication going on, you will fail the vertical line test, because you'll end up with this type of situation right over here. This type of situation where a single domain value will give rise to two or more range values, and it will no longer be a function. So that's one of those situations where you spoil your function. And another situation where you can spoil your function is where not all the domain values are represented by a range value. That is, if you look at your elements of your domain or your inputs, you have to have all those elements represented in terms of a range. If you don't have that, you violate your function and it loses the status of that function. So you can compare this video I presented to the first video I presented for this channel of mine, where I talked about the definition of functions, and you can see if I did a better job on this with this confusing topic. I hope I did a better job. Please like, subscribe, and share, and have a nice day.